Good afternoon. How many people saw this on Twitter the other day with the Apple Card and people going through the cycle of getting approved and then discovering that there's, they had this question about why were they disapproved, why didn't they get approved? In fact, I don't know if people were aware, but this sort of blew up the other day. There were lots of follow through, lots of excitement, a big sort of frustration with within the Twitter community. He got increasingly irate, asking all sorts of questions. Apple's customer service representatives are telling him that, it might be your credit score, but then he checks the credit score, it's not really the credit score. And of course, he's managed to, sort of call a fair bit of attention to this. He's a pretty high profile individual, so now we start getting people talking about, well, Apple could be doing a good job, and actually he's going to be, he'll be on CNBC talking about this, and then all of a sudden you get giant stories about it. People are all of a sudden writing, it's blowing up on Twitter, it's blowing up as a story, and the call center reps, the people that he's talking to are just saying it's the algorithm, it's not me, maybe it's your credit score, I don't really know what's happening. And this is really the fear that many people have around AI and automation. The challenge around machine learning is that they're going to make this kind of a decision and it's going to blow up on them. And it's not only going to get it wrong, it's going to get it wrong in a way that becomes publicly embarrassing. And it's challenging because when you start talking to your data scientists, they're happy to give you an explanation of why this might happen or what happened. But the explanation is just not super satisfying. At the end of the day, it's really the case that people are choosing algorithms and models that are very ambitious in what they're doing, and they're not necessarily explainable. It can make it very challenging for you to support people in working with those conclusions. And in my experience, it makes it very challenging to use those models as part of decision support. So I'm Richard Tibbetts. I'm the product manager for AI at Tableau. I was the CEO and co-founder of Empirical Systems, which is a technology startup out of MIT focused on explainable AI that was acquired by Tableau last year. My team delivered Explain Data, which was sort of launched this morning. We're very excited about that. It's in 19.3, and it's actually new updates in 19.4, more updates in 2020.1. And what I'd like to talk to you about today is explainable AI, what it means to explain or trust something. And I'd like to bring my colleague on stage to talk about a lot of different ways that these things can be integrated into Tableau, and how you can make use of this kind of technology within dashboards and within your own organizations. So, what are AI and ML? People really like to talk about definitions. And you can come up with definitions. You can, in fact, select lots of them. Machine learning is when the machine is going to retrieve a function, is going to figure something out, learn it from history. I'm very fond of the idea that AI is just any time the computer surprises you by doing something you didn't think computers could do. The important thing to realize is that everybody's really sloppy with this terminology. It doesn't really matter what you call it. And when you look at a product like Tableau, when you look at a system like Tableau, you can actually find many different opportunities, many different places where AI, machine learning can come into the system. Whether it's within the augmented analytics capabilities, things like Explain Data, or Ask Data, or it's about analyzing user behavior to generate recommendations, or it's about creating models, whether they're regression models or more sophisticated models, visualizing the results of models, understanding and monitoring. There's many different ways that these things can get brought in. And there are actually a bunch of really interesting talks here at TC about that. I recommend both How to Lie with Statistics as well as the Explain Data internals. I'm not going to dig into either of those. I'm going to talk a bit about what it means to explain AI, why we do that, and how we're going to get to a point where we can maybe trust these systems. So, these AI systems are often kind of an inscrutable mess. It's hard to know what's going on inside them, and that would be okay if they kept to themselves. But there's also like all these important real-life things, like healthcare and news curation, financial services, the criminal justice system. And for some reason, people really like the idea of just blindly connecting AI to all these important real-life systems. like that'll somehow make it better. And if that wasn't bad enough, they have a habit of also connecting those systems to the cloud, or as I might call it, the Internet of Hate. I guess people just call that the internet. But when you've hung these things together, you realize that if you don't know what the system is doing and you don't know what it's learning from its environment, you don't know how it's making decisions, it's going to be very difficult to predict when it will behave badly, when it might lead to one of those sort of embarrassing situations. And so explainable AI is something that's been a big research topic. A lot of DARPA funding going into that around the idea of how do we go from a process where we're building black box models to ways of building models that are explainable, or to ways of explaining models that we've already built. And there's a number of ways that people use explainable AI. You can use it in a reporting type of a context, where your goal is to produce some long document that explains how a model works. Or you can do it in a more interactive fashion. That was the kind of research that led to empirical. It was the idea of making something explainable by allowing the user to ask follow-up questions, ask multiple questions. And you might be using that in a context where you're having a human operator, a domain expert, in a role of approving the results. So sometimes people want a cross-check or an approval. Other times, you're actually interested in just justifying the results. So you have a regulator, or one thing that I was surprised to find is fairly common, is situations where people want to use the explanation to justify the conclusion the machine came to in order to encourage compliance by the human operator. I was talking to a Tableau customer that had built models for detecting money laundering, and they really wanted them to be explainable models, and that makes sense. But I was trying to understand why. Did they really think that their humans were better at detecting money laundering than the models would be? And they said, no, the issue is that the human who's receiving this result, they have to get on the phone with another bank and explain why we shut down a transaction, why we're having this problem. And they don't want to make the phone call if they don't know why they're making the phone call. So we need to tell them in order for them to know what to do or know where to follow through. And that gets into a question of, is it sufficient to explain something if you want people to trust it? If someone explains something to me, do I now trust it? Well, and that becomes a question of, well, what is trust? So trust is when I have an expectation for how the system will behave. I expect the decision to be right. I expect the decision to be well justified. I expect the decision to not embarrass me on Twitter. And trust comes from both understanding and time and consistency, being able to work with that system and see it evolve over time. And so it's important to realize that explainable AI and all the systems we're going to work through today are a big part of helping people to trust in the systems you build, but they're not the end. You also need to give people time and experience with these systems in order to really get to a state of trust. So one thing you can do with explainable AI, well, one thing I'm pleased to have done with explainable AI at least, is actually just use it to help people explore data. So what's going on in the context of explain data? We're trying to help people get from the what to the why, and I assume everyone at this point has seen a demo of explain data, but let me just refresh you really briefly on that. So explain data is a new capability of Tableau. What you're looking at here is data. This is a map of the city of Boston, which is where I'm based. And it's data about bike shares within the city and what stations people do most of their bicycle riding from. And so we've done a map, and the bubble size is stations where people do a lot of riding. And I might come into this and sort of wonder what's going on, because there's this station here right in the middle, the Prudential Center, which it's a fairly central part of the city of Boston, but still I'm a little surprised that it sort of spikes so high. And so when I click explain data, what's going on in the background, I see. What's going on in the background is we're building a collection of different models. We're at interactive speed, building many different machine learning models, first fitting the data that's on the screen, and then fitting other candidate sets of data in order to first determine how surprising is this. So we generate an expected range where we know what we expect to find, how much ridership we expect to find at stations. And we also generate explanations. In this case, there's actually a single extreme value where somebody rented a bicycle for 460 hours. And that's really just dragging this station, the average at this station, way out of whack. And so I can go ahead and come down here and actually add a new visualization, which will get me that same map, but now I've actually removed the extreme value. I can actually put it back in and then see it come out again. And when I take out that extreme value, now all of a sudden, these stations here like MIT are much more significant. MIT, Boston University, Harvard. I might click into those. I can say explain again, just keep sort of moving through this data. In this case, just a lot of ridership is happening there, and stations that have a lot of ridership have longer rides. But also the type of customer matters. If they're a subscriber, if they have a long-term subscription, they tend to ride a bit more. And there's a higher ratio of subscribers at this station. And so what we're doing here is really combining domain expertise with machine-generated explanations to help people better understand their data, to accelerate their exploration. And the way Explain Data works, and there's a talk on the internals on Friday, the way Explain Data works is first we fit a model to the data that's on the screen. Then we synthesize a number of candidate explanations and fetch data related to those explanations. And we synthesize additional models of all of those. Because what we're trying to do is say, how surprising is the data that we had at first? And what additional information would make it less surprising? And then a key thing that we need to do is we're not just looking for the biggest sort of magnitude contributor. What we're really looking for is what's the most interesting or what's the most informative. So then we go through a scoring cycle where we look for simple explanations. So we're going to prefer the simplest explanation that explains the largest portion of the variation. Because humans like simple explanations. I can explain anything by giving you the whole data table. Why is the station add up to that number? Well, here's the whole data table. What you want is a simple explanation that a human can get their mind around and they can use as a jumping off point to keep moving through the data. But that's just one way that you can be bringing explainable AI into Tableau. Now I have the great pleasure of bringing up my colleague Konstantin Gregor, who's in town he's coming in from Germany. He's a sales consultant who is vastly better with Tableau than I am, so he's going to show you a bunch of really impressive technical stuff. And he has not yet embarrassed anyone on Twitter, at least not with an AI.
That is true. Thank you, Richard, both for your introduction of myself, but also of the introduction of the topic. So yeah, staying on this notion of trust. I'm not really sure you should trust me when I attribute this quote to Richard, even though I think, first of all, it's brilliant and it totally could be his. But what I want to say with this is basically, when we talk about AI or understanding AI and being able to trust it, I guess what we should be doing is understand what can actually make us trust those models. And I believe one of those things can be if it's very simple, if I can understand it from a mathematical standpoint. So maybe not a division, that's probably too easy for you guys, but let's say a linear regression, for example. So who here knows what a linear regression is and how it works, roughly? So we're basically trying to explain the variance or the change in one variable by the change in another variable, and then adding some intercept and maybe an error term. So that's something we do understand, and because we understand it, we can also trust the results that come out of it. We can interpret them. Another way would be, maybe you trust us as Tableau. So you trust the models that we gave you, the drag and drop options that you have in the UI of Tableau, like we have the regressions, the different types, or we have a clustering and we have a time series forecast. Maybe another show of hands who has used at least one of these models? All right, perfect. So that is one way. And I want to show you a little bit of what this can look like in the tool. If I can. Here we go. So this is Tableau Desktop, as you know, and I also brought some cycling data, but in my case, it's around the corner. It's not from Boston, it's from New York City. It's also rental bikes. And as you all know, there's a number of factors that might affect the input if you actually do want to ride a bike or not. So there could be weather-related things like temperature, for example, and I can very easily build a graph that shows me, based on a daily level, the relationship between the temperature of each of those days and the, oh, sorry. There we go, that was wrong. That should be the temperature, and that should be the trips. I'm sorry about that. so that we can very easily visually see the relationship between those two variables. And if you're new to Tableau, this is kind of the value of the visual exploration of your data. You immediately see that this connection exists between those two variables. And the drag and drop modeling that I spoke about is hiding up here in the top left corner in this analytics pane. So if I click this, it switches, and you can see down here we have those statistical models. And the one that I'm currently looking at is the trend line. That's what we call the regressions. And you can also see those 5 different types of regressions we have. For now, let's just choose the linear one. So I drag and drop it in, and voila, there's my univariate linear regression. I can go even deeper and maybe hover over this regression line to see or to learn a little bit more about the relationship between those two variables. I can also see the R-squared, which tells me how much of the variance in the number of trips is explained by the variation in the temperature, and also the p-value, which gives me an indication of the statistical significance of that model. So in this case, we see it's pretty good. But the problem with those models, as nice as they are and as easy to use as they are, is that's kind of a dead end. So there's not really a whole lot I can do with those now. For example, if I want to display the R-squared value very prominently in my viz, it's not really easy to do. One hacky way to do that is to just open up a new calculated field and then mouse over your regression line and start typing the value here in the calculation. But that is obviously not very scalable, because the moment your data changes, those hard-coded values will not apply anymore. So this is, at best, maybe a first step, but it's not really reliable. So maybe we need to go one step further and calculate the regression ourselves. And this is actually not that hard. We saw earlier the formula for a calculation. So if I switch to this new worksheet here, we can see there is no regression line yet. But what I prepared over here for you in the data pane is already those variables, just so you don't have to watch me make many typos. But we can have a look, and this is actually what they look like. So I'm not going to go into detail, but as you can see, we do ship a number of functions. And maybe a little note for those of you on versions before 10.2, you will need to use a few table calculations, so the formula are a bit more complicated, but it's totally possible to calculate the slope and as well the intercept of your regression, and based on that you can then also very easily just put together the total regression. And then it also allows you to, for example, calculate things like the residuals, because that is very easy. From the actual values you distract the linear regression, and also things like the R-squared value that I spoke about. And now that we have all those things, we can very easily build the same plot that we saw earlier. So in order to do that, I'm just going to drag in the linear regression that we just calculated and build a dual axis plot. Make sure that the linear regression is actually shown as a line. Remove the color here, and voila, there's our regression line. This is basically like the manual way to do the same thing that we just did with the drag and drop. But the nice thing is that I can also calculate all those other things. So for example, if I do want to show a residuals plot, I can very easily do that. I'm just going to build another plot here. So on the top we can see the regression again. On the bottom we can see the residuals. And for those of you who don't know what a residual is, that's basically just the difference between what my model calculated and what the actual value is. And ideally the average of those residuals should be 0 in order for the model to be trustworthy. So I can then just use one of my other drag and drop models here in Tableau to just drag in this average line. And as we can see beautifully, it comes to 0. So again, apparently this is a pretty good model. So those are the things we can do with regression in Tableau if we do it manually. But this is not the end. We can also do things like, for example, I mentioned that there's many different variables in the weather, for example, that affect the number of bikes that might be rented on a certain day. Not just the temperature, but also things like precipitation. Did it rain? How strong was the wind? And I can very easily create a pair plot like this, just comparing everything with everything else. It's a bit overwhelming, so maybe if we just focus on the first line, I can also color those by the correlation coefficient, which we already calculated. And here I can very easily see the positive, the negative correlation between those variables. That is nice. But maybe again, for a statistically non-inclined end user, this might be a bit too much, too overwhelming. But using Tableau, we can leverage things like parameters. This is not even a dynamic parameter, just a good old parameter. We can use that to just focus on one variable. So currently I'm looking at the correlation for temperature, or maybe I want to look at the correlation for wind speed. And so I'm currently changing those values over here on the right-hand side, and this helps me to understand the correlation between one variable and another one. So I think this is actually a very nice way of showing how Tableau can show us, or can be used both in with the built-in models, but also with a little bit more effort to do those things. wrapping up on the built-in models, the good thing is that they're very easy to use. It's just drag and drop, good old Tableau style. And we also see that they generally perform better out of sample with those simple models. But then there's also the bad, and being a sales consultant working with you lovely customers day in, day out, you won't believe the horrible things I have seen customers do with those drag and drop models, like trying all 5 different regression models until they see the story they want to tell their boss. So the easier a model is to apply or to use, the easier it also is to abuse it. So that's a bit dangerous. We also saw that it's kind of a dead end. So once we've done that, that's it. We can't really use any of those values. And there's also, there are some features to configure it, especially the other models, but not so much. So some people might say it's a bit too little. And then also the ugly. There's a number of quality metrics you can get out of it, but they have no context. So if you don't know what you're looking for, if you don't specifically know what you're looking for, you're kind of lost. So the question is, how can we ameliorate those issues? And I think probably if you're working in a bigger organization, you are a data scientist or you have a data science department and they have already developed some models here or there and you're using them in Jupyter notebooks or in Shiny applications. But the problem is how do you really easily visualize the results coming out of those models? Well, the good thing is that we can use those in Tableau, and I hope you have heard, who has heard about the external service integration in Tableau already? Okay, not so many. So let me introduce you to that. It means that you can connect Tableau to external services like R, like Python, like MATLAB, or using extensions you can also leverage a service like Data Robot, for example. And you can then use the visual power of Tableau to display or to visualize the results that those models produce and make them thereby accessible to anyone. Let me show you what that can look like. So this is a plot that looks very familiar. It looks exactly like the one we just produced with the drag and drop action, just a linear correlation, between a linear regression between the temperature and the number of trips. But believe me, this is actually calculated using R. So you might already see in the variable name that this variable is called R, but let me also show you the actual calculation for that, and you will see that it's actually very easy. So those 2 lines of code, and if you don't know R, don't worry, it's not really about learning R now, it's just about showing that we're actually running R code within a Tableau calculated field. And it only takes those 2 lines to do the same thing that we just did with the drag and drop thing. So you might ask, okay, Konstantin, why do I need to write 2 lines of R code, learn a new language, if that does the same than just my drag and drop action? And you would be right. The reason we want to use this is because we can go further than what the built-in models can do. Like, for example, a multivariate linear regression, which would look like this. As you can see, it's still pretty simple code for somebody who knows R, but it can do something that Tableau out of the box cannot do. That is a regression based on multiple input variables, like not just the temperature, but also the wind and the precipitation. So that's fun. And we can also, again, not just output the fitted values, but we can also fit the residuals. So that's easy, and we can use all those functions, and we can then, again, the same way that I just built this dual axis plot, I can then build this line, which in this case is built using R, or running R in the background. Now with a multivariate linear regression, the problem is that I can't really display that in a line chart anymore because it would look very weird and I need an n-dimensional chart, so that's not really feasible. So instead what we can do here is maybe show the residual plot again. And again, this is basically based on 2 R calculations, the fitted values on the x-axis and the residuals on the y-axis. And we can do the same test again, just drag it in our average line and hopefully see that it averages out at 0, and it does. So again, my model produces a really meaningful result. So that's nice. But the point where it gets really interesting is when you leverage really complex models. Like, for example, in this, it's not beautiful, but it works, in this forecasting cockpit dashboard. What we see on the top is a line chart of the development of my sales, and then in the end we have the prediction. So the orange part of the line, that is values in the future. They are predicted by my time series forecasting function. But in addition to this, I also have 2 other influential variables, like the marketing spend and the number of salespeople on my team, that affect this forecast. And using the power of interactive Tableau dashboards, I can then have corrections in my variables. So for example, let's just go to the very extreme. I'm cutting all the marketing spend, and you can see how not only this chart down here changes, but you could also see briefly the calculation dialog, and you can see how my overall sales also are changed accordingly. And then let's also change maybe the number of salespeople to kind of counter the marketing spend that we cut. And again, you can see on the top, after some calculations, how you can see the plot has changed. So this is a little bit more advanced. And I want to show you what this looks like in practice. And again, don't be afraid when we're looking at the actual calculation. It's not about learning how this works. Just want to show you some really cool technique. Because this is basically the code that we're running. And as you can see, it's a bit more complex. So maybe this is a model that your data science department has already developed over the past months or years, and you're using it in multiple dashboards and multiple points in your business workflow. So by putting this code verbose, one by one, into all the calculation dialogues and all your workbooks across all your organization, introduces a big problem, because if you want to change something, maybe you want to change the model, or you want to update the library you're using, or maybe you found a bug and you want to fix it, then you have to go through all the instances of your workbook and fix it there, which is not really scalable. So there is a really cool way to come around this, and for that I'm just going to take my code, copy and paste it, because the thing is, this service that we're currently running in the background that allows us to run our code is called rserve, and when we are starting a new rserve session, we can actually give it some parameters, like preloading libraries that take very long. There's no point in loading a library a gazillion times. It's enough to load it once, and we can maybe save a lot of time by doing that. But we can also paste this function code in here, and thereby kind of wrapping everything in this new function called MVTSF, multivariate time series forecast. The only thing I'd need to do now is to change this .arc notation that those of you who have been working with external services, this is just how we transport the variables between Tableau and the external services. I would need to change those to the actual function names. And when I do this, or after I've done this, I'm not going to do it now, I can basically just rerun R. Let me just do this very quickly. And what I can then do, whoops, nope, that's not what I wanted to do, sorry. Well, I'm not going to do it now. So what I can do is I can actually run or initiate my rserve session by running this config function, which sources the code that I just had. Which means every time I initiate this rserve session, my function multivariate time series forecast will already be populated in this session, so people can just use it, just like any other function in R. Which also means if I, as the data scientist, want to fix something, I don't have to go to all my 1,000 workbooks where this function is actually being implemented in the calculated field, but I can just go to this one spot here in my configuration file, make the change, restart the rserve session, and everybody's using the updated version of this function. So I think this is a really powerful technique to actually make the models that you develop in your external services really scalable across your organization. Sorry that this didn't work right now, of course. So the beauty of it, as I showed with this dashboard, is that everybody can use a very, very complex statistical model without necessarily having to know what's happening in the model. They don't care. They just know, okay, I can turn some knobs here and there, and then something changes, and I know what I need to know. So they're still able to use the statistical functions, but they don't need to know how it actually works. The other thing that I showed is the scalable management of those models once you deploy them to your external services. In the next step, we will also see how this all works with Prep. So if you want to integrate some statistical models or machine learning into your ETL process, that is also possible. And as I mentioned, so there's a number of extensions on the extensions gallery already that allow you to connect to external services, like for example, Data Robot, which is really cool. But it's not all beauty, there's also the beast. So as you might have seen, the connection to external service, or the functions that actually connect to those external services, those are table calculations. So everybody who's worked with table calculation knows they're a bit more intensive to kind of configure to make sure that the addressing and partitioning is right. And also you can't really do a whole lot with whatever comes back from a table calculation because they're so far down the order of operations. So that's something to keep in mind. And the other thing is, and that kind of leads us over to the next point, is you can't really reshape your data. Because the structure, or the way we build those table calculations is that you can only input a number, like for example, a vector of number 100, or multiple of length 100, but the return vector has also be of the same length. And also there can only be one return vector, which might be a problem if you want to return a whole data frame, like multiple variables. So this kind of brings me to the third and last point, is how can we, for example, visualize the key factors in a model? Because this will help us to actually make a model that is easier to trust, because we understand what's happening, what is really driving this model, and maybe we can even make it simpler by reducing the number of features. So we're doing something called impact analysis. For example, building a correlation matrix, or identifying the most important features. Or as I said, reducing the data set, so we're only leveraging the most important features, maybe giving up a little bit of accuracy, but instead making the model easier to understand and also faster to run. So this brings me back to the issue. The problem is that the table calculations in Tableau Desktop can't really reshape your data. So building a thing like a correlation matrix is actually impossible. And this is where Tableau Prep comes to the rescue, because we can just use everything in our models there. We can reshape the data, just export it to CSV, to a hyper extract. We can publish it to a server, or in the near future, we will also be able to put it back down, push it back down to the databases and work with those data sources in our workbooks. Let me show how this could look like. So first of all, I want to build this correlation matrix. And as I said, I can't really do this in Tableau Desktop. So let me just switch over to Tableau Prep. This is a prep flow that I call the Feature Importance Toolbox. And by the way, you will be able to access all the materials we showed today afterwards. And what this does, it just takes, this is a different data set, it's a breast cancer data set. It just takes this data set and then runs a number of models to actually do the things we want to do. The first one is this blue flow up here on the top. This is just building the correlation matrix. And as you can see, I'm actually leveraging, let me zoom in so you can actually see it. We are leveraging some R code in here. So this function correlation matrix in the file correlationmatrix.r, this is the function that we're actually running. And let me briefly show you what this looks like. This is basically it. So again, a number of code on the top, that's not really that important. Important is that it does actually calculate the correlation matrix. The interesting part is that Tableau Prep allows us to return a data frame. So we can actually return multiple columns, like 2 strings and 1 decimal here. And that is basically what's then written to the CSV file, and this is the correlation matrix we can use. So once I connect to this data set in Tableau Desktop, I can very easily just put my values out here, put those on text, have actually, whoops, no, not on text, sorry, on color, and very easily identify, for example, what's happening with my data. I could then even go one step further and say, okay, I want to maybe use this correlation matrix to eliminate the things that are too strongly correlated, because this is going to introduce bias to my model. So maybe everything that's stronger than 0.9 should be eliminated, and just like this, I can see which are the models or which are the features that are very strongly positively or negatively correlated. So maybe I should leave one of those out, because otherwise they're going to introduce some bias. So that's a very, I think, easy way to work with that. The next function I implemented here is the feature impact, like which are the most important features. I'm not going to show this in detail. I already prepared this for you. I could then, for example, build a plot like this, which just ranks the features by importance, and we can see up here the most important one are worst perimeter, worst radius, worst area, and worst concave points. And then I can work from there, for example. But the last step is where it gets really interesting. This is my feature reduction. So now that we have identified which are the most important features, I want to cut down my data set to only those, and then do all the future analysis based on only those, on this reduced data set. So I did this here already, because this is a kind of a complex model, but we can see that it basically spits out the 4 variables that we're looking at. And actually, let me just briefly run it so you can actually see that something is happening. Everybody loves a console. So this is now doing a 10-fold cross-validation. So this is going to run for about 20 seconds, I think, and actually trying to identify, using recursive feature elimination, which are the 4 or the n most important features that are going to spit out those 4 variable names, and then we can continue working on it. And what I can do with this reduced model is then, so I built a little dashboard here, which allows me, I hope you can see that, which allows me to compare. So I ran a random forest classifier on both the full data set, that's the diagram on the top, and the data set with the reduced features on the bottom. And as we can see, they both perform pretty well. The top one with an error rate of 4.5%, and the bottom one, even though we cut it down from 30 variables to only 4, still only at an error rate of 7.2. So still pretty good, but we significantly reduced the complexity of the model, and by the way, also the runtime. So I think this is really powerful, and this is a very good example of how we can use statistical or machine learning models to help us understand, or to make our models more understandable, and yeah, thereby also maybe hopefully a bit more trustworthy. We want to put this one step further now, and for this I'm going to ask Richard up on stage again, because he's going to show us how we can use Tableau to visualize the explanations for individual features, actually. So going one step further. Thank you so much.
Thank you very much, Konstantin. Yeah, thank you. That was great. So we talked about using simpler models. We talked about visualizing the attributes that are driving a model, helping people to understand what's going on. the last thing I want to take you through is visualizing an explanation for an individual prediction. So this gets back to some of that explainable AI research that I spoke about earlier. You have the idea of a model that already exists that might have been created by some process, and that model might tell you whether or not something is a picture of a cat. And what it means to get an explanation out is for a given picture that the model decides is a cat, you'd like it to tell you, well, why did it think this one was a cat? And sometimes it might give you features that are very well labeled or well understood. It has fur, it has whiskers and claws. Other times it might give you features that the model doesn't necessarily have context for what they really mean, but once you show it to a domain expert, and a domain expert in cat pictures is anybody over the age of 3, once you show it to a domain expert, they can say, oh yeah, those are cat ears. That's sort of what I expect. And so the idea is to give people an interactive environment in which they can get those explanations, for any given prediction that they might be facing. And so I went ahead and brought in a system called Lime. So Lime, and there's another system called SHAP that has some similarities. There's a number of different research areas for this. But Lime gives you, it stands for locally interpretable model explanations. And the idea is to give me an explanation for a given prediction, for a given part of the model. And we've gone ahead and done pre-processing, which I personally happen to do in a Python notebook. One could do it in Prep just as easily, but we've pre-processed the data. And let's look at what that looks like right here in Tableau. So here I have a dashboard, and I've brought in data that is about military households. So we can see we have some different attributes of the data, the marital status, the age, how much of education that they have. And what we're trying to predict in this data, what we train the model to do, is to predict the likelihood of the household income being greater or less than $50,000. Now that model, and I had this question yesterday, what model did you train? And literally I don't remember. We used whatever scikit-learn thing happened to be lying around. It doesn't really matter where the model came from in order to do this kind of explanation. That's actually the real power of Lime, is that we can start with any predictive model as long as we're allowed to repeatedly invoke that model. So what I get when I've done that is I can mouse over, and thanks to the miracle of Viz and Tooltip, I can see the factors that influence the decision by the model in this particular case. So for example, we think it's very likely that this person in their household has a lower than $50,000 a year income. And that's because they showed no capital gains tax on their taxes. They have less than a high school education. They working a lot of hours per week, so that's usually a good sign. As you can see, it's moving in the positive direction. So you would think that people who worked a lot of hours per week, that would sort of push you towards higher income. But because it's in this sort of other service sector, then we think it, again, is less likely. So these different factors come together. An interesting thing about working with a model explaining system like Lime is you'll get different explanations for different records. For example, in this case, this person is young, and so we're going to treat that as significant, and they're never married as opposed to being widowed. And in this case, not having been married is sort of a top feature. I can go ahead and sort these to go find some people who we're very sure have a high income. And what you see come out of this is, oh, okay, as soon as someone has capital gains on their taxes, we're pretty sure they're a high income household. That's sort of not an unreasonable feature for the model to have really latched onto. Being married to a civilian spouse helps. There are some people here who have no capital gains, and yet they still come out as a very high likelihood of having this higher family income. In this case, the no capital gains is pushing them down, but they sort of come back because of the marrying to a civilian spouse, working 50 hours a week. The civilian spouse, the occupation is executive managerial, and they're sort of in their mid-40s, or they're 41 years old, which puts them sort of right in prime earning years. So an interesting thing about this is you can get an explanation for each of the decisions that the model's making. It can also help people who are not as familiar with data science get a handle on what happens in this sort of middle where we're kind of uncertain, where we're being pushed in a variety of different directions by different features. So what's going on under the covers in order to make these kind of explanations happen is we're repeatedly evaluating the model at points that are in the neighborhood of the point that we got a prediction for. So what I'll do is, what the system will do underneath is vary different variables. And what it's looking for is what's the decision surface, there's sort of a hyperplane through this high dimensional space. And where is that hyperplane near this point? So how far do I have to move away from this point and in which directions to get a different answer? It's sort of like if you ask someone to price your house, to estimate the value of your house, and then you started probing and said, but what if this, what if that, what if that? So that's happening automatically. This is great for those kind of scenarios I described where you're trying to deliver compliance or sort of justifying after the fact what happened. Why did this decision get made? In fact, this would have, to some extent, addressed that initial Twitter problem. It helps you understand what explains this decision. That being said, it's actually not a very good approach for approval because it's always going to give you its best evidence. And it may well be the case that the model is making sort of wrong decisions. And if it's making wrong decisions, the local decision surface may still seem truthy to a domain expert when in reality, there's something flawed with it. So you need a different approach if you wanted to look into why would I expect the other answer? Why would I expect the opposite to be going on? So that's sort of how we bring Lime explanations into Tableau, and how we allow people to interact with those so that they're not only seeing the results of a model, as Konstantin showed you, but they could actually be seeing explanations of that model that are specific to the prediction that drives the particular mark that they're looking at. So I know we've moved fairly quickly, but we've gone through a pretty wide range of things. We talked a bit about what does it mean for AI to be explainable? Why would you want that? What does it take for someone to trust a system? What does that really mean? And then we talked through a number of approaches. We talked through how we do things like explain data, how we do things like bring in building models, build models that are very simple within the context of Tableau, or bringing in third-party models. And we talked about synthesizing explanations for a particular model. So what can we conclude from that? What do we bring together on that? So explainability is a really big concern around AI and machine learning. It's something that people may come to you to ask about, or in other cases, it's something you may feel entitled to go to your data scientists and say, why aren't we doing a better job with this? Why aren't we looking at some of these new systems? The best way to deliver trust and explainability is to choose the simplest model possible. One thing I see again and again is people being very fascinated by technologies that can deliver them very sophisticated models. And oftentimes those very sophisticated models deliver them only a very tiny performance improvement on their training or test data set. And frequently they end up being quite fragile and quite difficult to explain to people when they degrade, such that they're out of sample performance, as Konstantin mentioned. Their performance on data they've never seen before can degrade very quickly and precipitously. And so when you want to understand what's going on, when you want to deliver trust, it really does help to get visual with people and help people have interactive experiences. And so bringing these kind of explainable techniques, not only to bear against your models, but bringing them into a familiar visual environment like Tableau can help people within your organization get comfortable with what's happening. So that's what I have today. We're happy to take a couple of questions. If anybody, there's a microphone for people on the other side. You have to come around to this microphone in order to sort of capture that. So we'll take, 1 or 2, 3 questions, depending on what's going on, if I can get anyone up. But unfortunately, this time I have no plant in the audience, so no one's going to move first unless it's you. Well, I will be up here as well as Konstantin, and happy to take questions one-on-one, take things offline. Thank you very much.